Good day, grade 9. Here is your reviewer in Mathematics 9 for third quarter, part 2. Let's get started. Question number 1. The lower base angle of an isosceles trapezoid is 30 degrees. So, the measure of the upper base angle is blank. Now, remember that for an isosceles trapezoid, the non-parallel sides are congruent. So the left side here and the right side here are congruent. And also the adjacent angles of this isosceles trapezoid, first angle from the lower base and the second angle from the upper base, are supplementary. So when they are supplementary, the sum of these two angles is 180 degrees. Now, since you already have a 30-degree measure here, so what should be the measure of this angle here? Let's just say it's an x. So again, since they are supplementary, you can say that the sum 30 degrees and x is equal to 180 degrees. But since 180 degrees and 30 degrees are similar terms in this equation, then you can just leave x alone by transposing 30 degrees to the side of 180 degrees. So you have 180 degrees minus 30 degrees. So you get x is equal to 150 degrees. Therefore, the measure of the upper base angle is 150 degrees. So that's the answer. Next question. If the diagonals of a kite are 12 inches and 18 inches respectively, so let's insert the word respectively here. Respectively, then the area of the kite is blank. So let's just draw typical figure of a kite. So imagine this is the kite and here are the diagonals. So the smaller diagonal is 12 inches and the longer diagonal is 18 inches. Remember that to solve for the area of a kite is equal to 1/2 of the product of the two diagonals. So let's assume D1 is the diagonal 1 and D2 is the diagonal 2. So by substitution, 1/2 times diagonal 1 is 12 and diagonal 2 is 18. You can do cancellation technique to facilitate the multiplication. So you just divide 12 divided by 2 in the denominator of our fraction. But 12 divided by 2 is 6. So you can have 6 times 18. Just multiply them. 6 times 18, that's 108. And since it's an area, inch times inch or square inches. So this is the area of the kite with the diagonals 12 inches and 18 inches. Okay, let's move on to the next question. The area of a kite is 36 square centimeters and one of its diagonals is 12 centimeters. Find the length of the other diagonal. So if this is your kite, so let's just draw a typical figure of a kite. And one of the diagonals is 12, but we do not know if which diagonal is 12 centimeters. So let's just assume that this one is the 12 centimeter diagonal. So we do not know the length of the other diagonal. Let's just represent it with x. Applying the formula to get the area of a kite, which is A for area equals 1/2 times the product of diagonal 1 and diagonal 2. And since the area is 36 square centimeters from the given here, 36 square centimeters, let's substitute A with 36 equals 1/2 of diagonal 1. Let's just say that the diagonal 1 here is 12. So 12 times the diagonal 2, which is, let's say, x. Then simplifying, you get 36 equals, applying cancellation technique, we get 1/2 of 12 is 6. So you have 6x. Then dividing all by the coefficient of x to leave x alone, then you get 6x over 6, also 36 over 6, then x equals 36 here divided by 6, or that's 6. So therefore, the length of the other diagonal is 6, and the unit of the length given here is centimeters. So 6 centimeters. Okay, next question. How much would you sell a lot at 1,000 pesos per square meter if it is in the shape of a rhombus whose diagonals are 50 meters and 60 meters? So from this, you need to get the area first of the rhombus. Then after solving for the area of a rhombus, you have to compute the cost of the lot which is in the shape of the rhombus if the cost of the lot is 1,000 pesos per square meter. Now remember that the area of a rhombus can be computed by using the formula area equals 1/2 times diagonal 1 times diagonal 2. Now, let's draw a typical figure of a rhombus to figure out the situation. So, one diagonal has a measure of 60 meters and the other diagonal has a measure of 50 meters. So by substitution, the area is one half of diagonal 1. Let's assume that the first diagonal or the diagonal 1 is 50 and the other diagonal is 60. So area equals, by cancellation technique, we can just divide 50 by 2, which is 25. And 25 times 60, you get 1,500. So the area of the lot, which is in the shape of the rhombus, is 1,500 uh, square meters. Square meters. Now, since the cost of the lot is 1,000 per square meter, so let's just multiply 1,000 pesos per square meter multiplied by the total area, which is 1,500 square meters. So you have 1,000 times 1,500. That's 1,500,000 pesos. So in short, that's 1,500,000 pesos is abbreviated as 1.5 M or 1.5 million. So that's the final answer. The cost of the lot, which has diagonals of 50 meters and 60 meters, is 1.5 million pesos. Next question. A steel gate 3 feet by 4 feet is to be reinforced by a brace by joining its non-adjacent corners. How long is the material needed to connect the opposite corners of the steel gate? So it seems like the gate is in the shape of a rectangle, which has the dimensions of, so let's draw a rectangle which is or which has the dimensions of 3 feet by 4 feet. Now, there is a brace which joins the non-adjacent corners, meaning from one corner down to the opposite corner of the rectangle. So what is the length of this brace? Let's represent it with L. And as you can see, getting the half of this rectangle, the half of this rectangle forms a right triangle. And since the upper side is 3 feet, of course the lower side, which is opposite to the 3 feet side, is also 3 feet. So since you have formed a right triangle, you solve the length of the brace, which is the hypotenuse of the right triangle, by a formula called Pythagorean theorem. So 3 feet here. So the Pythagorean theorem, or PT, is given by the formula a squared plus b squared equals c squared. Let's assume that a is to be substituted by 3. So 3 squared plus b, which is 4 squared. And the hypotenuse c is to be represented by L. So L squared. But 3 squared is 9 plus 4 squared, that's 4 times 4 is 16, equals L squared. And simplifying, 9 plus 16 is 25, equals L squared. Then eliminating the square exponent of L, so you get L only without the exponent square. You extract the square root of both sides. So you can cancel out the square root and the square. And the square root of 25 is 5. So L equals 5. Therefore, the length of the material needed to connect the opposite corners of the steel gate is 5, and the unit is feet. 5 feet is the answer. For the next question, what is the area of the largest kite that can be constructed out of 14 inches by 18 inches rectangular Manila paper? So the Manila paper, which is in a rectangular shape, has dimensions of 18 inches and 14 inches. Now you are going to construct a kite out of this 14 by 18 rectangular Manila paper. Naturally, the kite would look like this. So the diagonals of the kite are the dimensions of the rectangular Manila paper. So the longer diagonal is 18 and the smaller or shorter diagonal is 14 inches. Therefore, the area of the kite that can be constructed out of this Manila paper is again using the formula 1/2 diagonal 1 times diagonal 2, which is 1/2 of, let's just say the first diagonal is 14 and the other diagonal is 18. So by cancellation, you can divide 14 by 2 and you get 7. So you multiply 7 times 18, which is 126. And since it is an area inch by inch or inches times inches, so you get inch squared. 126 inches squared is the area of the kite, the largest kite that can be constructed out of the 14 by 18 inches rectangular Manila paper. Next question. In parallelogram LOVE, as shown in the figure, LS equals 3x plus 5 and SV equals 4x minus 2. What is the length of diagonal LV? So the diagonal LV is this one, and the LS, which is the half of the diagonal LV, is 3x. So 3x here, 3x plus 5, and SB here is 4x minus 2. But since in a parallelogram, the diagonals bisect each other. Therefore, LV is divided into two equal parts. LS equals SB. So we can equate LS to SB. They are equal. But LS has a length of 3x plus 5, and SB has a length of 4x minus 2. Again, by combining similar terms, 4x is to be combined with 3x to the right side. So 4x minus 3x, while 5 is to be combined with a term similar to it, which is negative 2, and negative 2 becomes positive 2. So 7 equals 4x minus 3x is x. And from that, what is the length of the diagonal LV? We will get one of the halves of the diagonal. Let's say LS. So we have to get its length. The length of LS, 3x plus 5. But x, as we have solved, is 7. So you get 3 times 7 plus 5. But 3 times 7 is 21. So you get 21 plus 5. So LS is equal to 26. But the whole diagonal is twice of this LS, which is LV. LV is twice of the diagonal LS, which is 26. So LV is 26 times 2, which is 52. 52. So the answer is 52. Next question. The length of two sides of a rhombus is 5x and 3x plus 12. Find the length of the sides of the rhombus. Again, the sides of a rhombus are all equal. One side is 5x, while the other is 3x plus 12. But since all sides of a rhombus are equal, then we can say that 5x is equal to the other side, which is 3x plus 12. Again, since it's an equation and we combine similar terms, so we get 5x minus, we transpose 3x to the other side. So 5x minus 3x equals 12. But 5x minus 3x is 2x, which is equal to 12. Now, eliminate the numerical coefficient of x, which is 2, by dividing all sides by 2. So you get 2x over 2 and 12 over 2. Cancel it out. Cancel 2 out. So you get x equals 12 divided by 2 is 6. From here, the length of the rhombus is, well, let's get one side, which is 5x, to get the length of the rhombus. So 5x is 5 times 6, which is 30. So therefore, the length of the side of one side of a rhombus is 30. That's the answer. Next question. Compute the value of x to make the proportion x plus 3 is to 4 equals x is to 2. So from our proportion x plus 3 is to 4 equals x is to 2. Remember that in a proportion, the product of the extremes is equal to the product of the means. Since the extremes are x plus 3 and 2, and it is equal to the product of the means, 4 times x. Now, simplifying our left side of the equation, because one part is enclosed by parentheses, so we have to remove the parentheses by distribution, or distributive property of multiplication over addition. So we get 2 times x is 2x plus 2 times 3, which is equal to 6 equals 4x. Again, combining similar terms, we get 2x transposed to the other side. So we get 4x minus 2x equals 6 on the left side of the equation. So you have 6 equals 2x. But of course, we have to eliminate the numerical coefficient of x, which is 2. So we have to divide all sides by 2. So divide also 6 by 2, and you get 3 equals x. Or interchanging the positions of 3 and x, we get x equals 3. So the value of x to make our proportion correct is 3. That's the answer.